Well, g'day, welcome back to the shop. Max here again. Late Sunday morning here in Perth. It's approximately about 11:30 a.m. and it's hot. It's going to be another sticky today. Already we're at 39 degrees Celsius. So today we're just going to digress a bit and we're going to make a set of forks for the tractor. Now, just out of scrap that I found in the scrap bit of work laying around. So, a bit of West Australian redneck engineering coming up. We'll make a start. So we have a heap of these L-shaped brackets made out of RHS I found. So I figured these will be a perfect start for a set of forks. So we'll crack on. Okay, we'll get some stock cut off for the brackets for the forks. These will be what attaches the forks to the bucket. So we have our high-tech drawing. Even though I do have a qualification in mechanical engineering drafting, this will do the job. Bear in mind, any resemblance between this and an engineering drawing is purely coincidental. So off we go. We've got 5 of these to make. Okay, for the deburring action. Okay, so we'll go off to the other bench. We'll mark them out and we have to bore some holes in for the pins. Okay, so we're ready to do our bores and the little mounting plates here. So if we go to our drawing, we'll just do an update on our CAD drawing. So basically that's a cross section of the bucket if you're looking end on into the bucket. So we'll have these brackets. They'll weld on here, the hole we've got there. Then our forks, which we have outside, will come down. Like that. We'll put a pin through there, through the bore, and that will hold the forks onto the bucket. So, bit of high-tech engineering there. We'll see how we go. So first up, we need to get our part centered up in the vise. So we use the old trusty parallels again. And I think I don't really have an end stop set up for this vise, so because this is such a low tolerance job, we're just going to put the scale across the end and we'll just push the part up against the scale. That will give us the reference back. So all we've got to do now is find the centre of the vise. So that's pretty easy because you can just eyeball it with a scale, or you can do it a bit more high tech. We use the back to the old starret last word again. Just shows a different technique for setting the vise up. We'll bring our quill down. Just ease our gauge out. More down on the quill. We'll get it close to the top of the vise. Swing around to the other side. Go that way a bit. Okay. We're just reading the high spot here. We'll come around to the other side. We've got a massive high spot there, so we'll come across a bit. All we're doing is equalising our measurements. We're not even touching there. Okay, we're centred there. We have the same reading on this side. So, okay. We can lock her off down here. And as usual, when you lock a slide off, you do need to recheck your gauge, make sure it hasn't moved, and in this case it hasn't. So that's good. Another good use for the trusty old last word indicator. Okay, so we bring our part up. Tighten her off. Now we've got to centre it and get our measurement back. So just for that one, all I'm going to do, I think, is use a centre drill. That'll be close enough. Get our measurement from here. So we are 37mm, 38mm. So we come back 38mm. It's only an approximation, so no, that's fine. So we'll lock our table off. We've got to start drilling our hole. Put the cutting oil, because it is steel. So we want a reasonable speed. 700 RPM. Okay, well that's the last of the pilot holes. We'll get the big drill set up. clearance holes in. So tape a wedge to remove the chuck. Just your Jacob's wedge. Oh, sorry, Morse tape a wedge. Okay, so our drill. Once again, make sure our tapers are clean. Just rotate it slightly so you feel the slot the tang goes up into, and ram it up home. We'll make sure we're not going to hit our parallels. Make sure we've got clearance there, that's good. The first one in. Our scale, we use our scale as a stop for the end, so she's in the correct position. Now we want to be drilling this on a slow speed, so probably we'll see what 145 looks like. We'll go with 80. A little bit chattery, but that'll smooth out once the drill hits its full diameter. And we're through. My brush. Tell you what, you put things down and they disappear. That's what I do. I'm sure that happens in every machine shop. The disappearing brush. Okay. Oh, they're a bit warm. So there's our pin bore. Plenty of clearance. We want lots of clearance. There's 3.5mm of clearance there for the pin, that's exactly what you want. So that take it up for any misalignment and that sort of thing. So, all right, we'll continue. Well, that's our holes done. Just keep the other parallel there, it just stops the coolant flowing down over this direction. So all that's left on these is to deburr these holes. A couple of methods can be employed there. Yeah, some nasty stuff here. We get rid of these. So a large countersink would be good. My countersink, my largest one, don't fit. So I'll have to go to another method. What we might use is we'll just use a bigger drill bit, we'll just use that. That'll knock the corners off okay. So we'll get set up and bring you back in a sec. Okay, to deburr these holes we're going to use a 1 39/64 drill bit, just a bit bigger than our other hole, so just carefully come down. That's alright, got a nice chamfer on there. Okay, so that's our parts all deburred, chamfered, ready for welding onto the bucket. So all we've got to do now is we'll put these bolts in the lathe, we'll part off the thread so they'll be at the required length, so the next operation will be in the lathe.